Greetings, the Astro 30 here again with more of a thought experiment here rather than actually a practical demonstration. Now, as the title says, we're looking at creating a simple guitar preamp, and here are its prerequisites. We want 2 times inputs of the same impedance and gain, so say 2 guitars. So we don't want a high impedance input and a low impedance input like most amplifiers have. We just want the same input impedance. A single input level control to control both inputs. A maximum of 4 op amps. Now what I mean by that is using, say, a TL074 or equivalent quad op amp, and we cannot use any more than 4 elements on the schematic, which is a challenge. Uses minimum components, features a bass, middle, treble control, a master level control, and above all else, cheap. Okay, so let's start with the input signal. Now I don't know how I'm going to do this easily in front of the camera, but I'm going to try. So there's our first capacitor and input. There's our second input. We're also going to have a input impedance resistor. This is really hard to do, and as messy as that looks, we've now got 2 inputs. Right, 1, 2. We're going to make them 1 microfarad each. We're going to make these resistors here 47k each, and these 1 mega ohm each. Ugh, that was really badly drawn. Let's try that again. Right, so we got 1 mega ohm. So most of you would think, oh well, let's just use 2 non-inverting op amps for each input and then mix the resulting output together. Well, you can, but that's already 2 op amp elements used. You can just use 1. So using an inverting amplifier, there's our negative, there's our positive, there's our ground reference, and we put in, say, a 100k resistor as our feedback. We now effectively have an input stage which is a summing amplifier which has a gain of roughly minus 2.1. So already we're ahead of the game here. Now, there's just one problem with using this type of circuit as in this arrangement and plugging high impedance inputs into a non-inverting amplifier. They do work, but they tend not to like having a high impedance input. They would prefer a low impedance input. So if you wanted to, I mean this will work as it is, but if you wanted to, you could actually add an emitter follower in the input here. Let me just draw that off camera so it looks a little bit cleaner. So here's what I mean by an emitter follower. We're just using a standard BJT transistor such as a BC547 or a 2N3904. Any generic transistor will do, even a 2N2222. Anyway, it's taking a high impedance input, so this 1 meg and this 1 microfarad capacitor are from the original input. We've just broken it away from this 47k mixing resistor here, passing it through the base of the transistor, going to the plus 15 volt rail, and we're taking the output off the emitter over this 4k7 emitter degeneration resistor, and this will give us a low impedance output. Now I have to make a correction here. I have made a mistake in this drawing and I haven't included base biasing resistors. So therefore this circuit on its own will not work as displayed. What we can simply do to fix that is to put 2 10k resistors in series with the base pin, so we're forming a voltage divider. One end going to the plus 15 volt and the other end of the string going to the ground, and that will base bias the transistor correctly. Going through another 1 microfarad blocking capacitor into our 47k mixing resistor, and then the other channel would be exactly the same. Problem with that is it's an extra 8 odd components. So here's input stage redrawn, so it's a little clearer, because yeah, trying to draw on side of a camera is not easy. So I'll recap. 1 mega ohm input resistors, 2 inputs, 2 1 microfarad capacitors, 2 47k mixing resistors going into the inverting input of 1 op amp, ground referenced on the positive, with a 100k feedback resistor giving us roughly a gain of 2.1 in the minus. Isn't that special? Now, we need to have a level control. So on that op amp's output pin, I have just drawn a 1 microfarad capacitor. Why am I using 1 microfarad? Because I had a lot of them. They're a common value and they give decent base pass. I'll comment on the input stage capacitors in a second. So here we're going through a 1 microfarad, going through a 100 ohm resistor. So that prevents the next stage from causing the first stage to oscillate due to high gain. Going through a 10k logarithmic pot, because it's a low impedance output, we don't need any higher than 5 or 10k. And then it will go on to the next stage. Now the next stage we'll actually add a little bit of preamplification, because we're going to need preamplification ahead of the tone control network, mainly because we're going to be using a passive tone control network rather than an active one, so it saves using an op amp. Okay, and now I've just drawn the next part of the preamplifier, which is the final part, the output section and tone control network. Now, as complicated as it looks, it's pretty simple. We've got a non-inverting amplifier giving us a gain of roughly 3.2 with the 22k feedback resistor and the 10k gain resistor there, going into this passive tone control network. Now, some of you may recognize this as similar design to a Marshall or a Fender, especially the Fender Bassman tone stack, which is effectively is what it is. It just uses lower value, more easily attainable potentiometers, and the values have been messed around with. Now, this came off of Rod Elliott's Sound Pages website on his 100 watt guitar amplifier Mark II. Uses that same circuit. I'll put a link in the description down below for that if you're interested. So we have a treble control here, which is our output comes off of that through a 100 ohm resistor again. So the 1 nanofarad will attenuate the high frequencies. Then it goes through these two networks here, a 220 nanofarad for the bass, and you'll notice they're wired as variable resistors rather than potentiometers. So each of these points here is clockwise, and this will attenuate the bass frequencies. And this is a 100 nanofarad, that's what it's supposed to say, going across this middle pot, which will attenuate the mid frequencies. Now keep that in mind, it attenuates the frequencies, it doesn't boost them. So you're attenuating the treble, you're attenuating the bass, and you're attenuating the mid, not boosting it, because, well, that's how passive tone control networks work. And then finally we go into our master volume control. It's not marked, but this is the master one. It's another 10 kilo ohm logarithmic pot. It's low impedance path here anyway, so it doesn't need to be any higher than that. Going through a 1 microfarad capacitor into a inverting amplifier circuit. Now remember, our input stage, basically our summer, is an inverting amplifier, so the signal is going to be 180 degrees out of phase with the input. This buffer here provides a low impedance output to the power amplifier, gives it a 180 degree phase shift, so putting it back in phase with the input, and also providing a little bit of gain. In this configuration we're looking at a gain of roughly 2.2 minus. So with that said, you're looking at a total overall gain with all the level controls set to maximum, these set at the center, around about 16, thereabouts, which is okay enough. Then the output goes through another 100 ohm resistor for obvious reasons, as previously explained, through a 1 microfarad capacitor, and there's our output. Now, just a quick note on this tone control network. Now, as it stands, this will pass the signal quite happily when one of these is full and these are minimum. However, when all the controls are set to their minimum rotation fully counterclockwise, you will have no audio signal pass at all. Why? Because this is counterclockwise, the signal can't go this way. So the signal has to go this way and that way. If this is counterclockwise, the signal can still go this way because this is counterclockwise, and so the signal is going to come out through this direction. But if this one is counterclockwise, the signal can't go anywhere because it's now attenuated to ground. So that's the reason why you'd have no output. So if you test this circuit and you haven't got these tone controls set in their rough up a little bit, or at least in their mid position, you're going to have no sound and wonder why. That is the reason why. So that's a trap to look out for, that this passive circuit where it works does have that minor drawback. But of course the life of a guitar preamp or amplifier in general is not going to spend the majority of its life with the tone control set to minimum, ever. There's going to be at least one turned up somewhere. So in all, we've used 3 op amps, so we have ticked that off the list. We do have 2 inputs. I haven't got the input stage here shown, but I do have a drawing on paper. In fact, I might put that up on screen. Okay, I don't know how well you guys can see that, but we've ticked off our prerequisites. We do have 2 inputs with the same impedance, same gain. We've got a single level control here. We're using a maximum of 4 op amps, or op amp elements, 1, 2, 3. We've used minimum components. It does feature a bass, a middle and a treble control. Has a master level control. And above all else is cheap. I put the cost of the BOM there, the bill of material. If you use, say, a TLO 7.4 op amp or similar, they're only about $2–3. Components, you're looking about probably, I don't know, $15 maximum for all the other passive components around it, including pots. So you could easily build this for $20–25. Next question is, does it work? Yes, I can guarantee you it does work. I have built a similar circuit in the past. However, as I said, this is a thought experiment, not a practical demonstration of a circuit working. 2 things to look for. If you either have too much gain or not enough, you can increase this 100k feedback resistor here on the first stage to say 150, and that will give you roughly 3.2. You could increase this resistor again to say 47k, that'll give it roughly a gain of 3.6. I'm just pulling those figures out of my butt, I haven't calculated it. I will calculate it in a minute. Or if you've got too much gain, just reduce this resistor down to 10k, so you've actually got a 1-to-1 unity buffer with a low output impedance. Now I was going to talk about the input capacitors. Now these input capacitors, if you find that the preamplifier is too bass heavy, that is, it's got a low end waffle to it, you can simply reduce the value of these resistors. Say you're using a bass guitar, for instance, or you want to roll off the bass of an electric guitar. You could drop this value down to 220 nanofarad, or 0.22 microfarad. Or you can go even further and roll off the bass a little bit more by putting a 100 nanofarad capacitor there, or a 0.1 microfarad capacitor. And that'll give you a little bit of bass roll-off. What that frequency roll-off is, without measuring it, I can't tell you offhand. There is a capacitance filter capacitor, RC filter calculator that you can use to work that out, but that's beyond the scope of this video. Now, is this circuit practical? No, not really. It would probably be a good idea to use emitter followers in the input path here, but that, as I said, that's an extra 8 components that you probably necessarily don't need. However, this whole entire circuit could be built up on a small piece of PCB measuring no more than 60 millimeters by, say, 30 millimeters. So a really small size board. Obviously with the pots not mounted on the board, you wire them off of standoffs, so you've got no limitation to your front panel of how you lay your controls out. You could even go as far as mounting the passive components for the tone control network around the pots themselves on the front panel. So you'd have an output point here on your PCB, and same as the level control, an input point here. So you'd wire all these 4 controls up to each other on the front panel. Easy enough to do. And that will save a lot more board space and won't make it look as crowded. Anyway, I hope you enjoyed this little short video about how I would go through the design process of making a simple guitar preamplifier with minimum components and still get the job done. If you did, remember to like, comment, rate and subscribe below. And you can always follow me on Facebook and Twitter. The links are in the description. Well, yeah, you can't follow me on Twitter anymore because I haven't got that link in there, but you can definitely follow me on Facebook. And if you're not a Patreon, you can become a Patreon. The link's in the description. You can be a Patreon for as little as $1 a month. Any little extra that you can become a Patreon with, the better it helps my channel out. But I'm not begging you for money. Just keep that in mind. Anyway, hope you enjoyed that. You could use the 4th op-amp element that's left over as a line output buffer or a headphone amplifier. It's up to you. So I'll leave this with you. You can build it, test it, modify it, redesign it, or come up with your own. I'll be interested to hear your thoughts and suggestions down in the comment section. Alright, well, this is the Astro 30 saying, see ya. Thank you very much for watching.